Alright, it says find the volume of the region bounded by the curves y equal x and y equal x squared rotated a around the x-axis. Now this is found on your notes, the worksheet I gave to y'all on Monday, uh, March 7th, uh, example 4. So of course remember we talked about dishers and the disc, I'm sorry, and the washer method. Well, this would be an example of the washer method. If you think about uh, that height, each rectangle, right? Still gonna be dx and still gonna be a y distance here. The only difference is when I rotate this, when I think about this being rotated, let me take that away. All right. So I'm gonna try to get it to where it looks. It's gonna be something like that. But from here to there, I'm gonna have a hole in my disc. And remember we talked about the washer is like a disc with a hole in it. All right. So if I think about the volume being the volume that's generated, the total volume, right? That's gonna be basically, if I say not total volume, I'm sorry. Let's just say the washer, the volume of the washer. It's going to be the total volume without the hole. So we say the volume total. Then minus the part I don't have. And that's the volume of the hole. Right? Alright, so what will be the total volume? Well, that's disregarding this x squared piece, right? I'm just saying that the radius would go from the base, my x axis all the way up to the line y equal x, so it's just going to be that height. So that should be pi times, remember the radius is that height, so that's times x, because that's the height, squared, and that's times the height of the whole washer. That's the change in x dx. All right, and we're going to be integrating that, and it's going. One of my limits of integration was where these two are equal. So that's from 0 to 1. And I'm getting that because I set the two functions equal to each other. And x is equal to x squared when 0 equals x squared minus x. And that just be taking the x to the other side. Factor out the x, I should have 0 equals, if I factor out the x, I'm left with, on this term, x minus 1. So that's where we're getting the 0, because we said each one of those terms equal to 0. X is equal to 0. It's going to give me 0, and x equals 1. It's going to give me the other one. So that's the total. then minus the whole. So we still on that same integral from 0 to 1. What's the volume of the whole? Well, the volume of the whole, its radius is going to go from the x-axis up to this bottom curve, which is the y equal x squared curve. So my radius there is going to be this function here for the whole, the bottom function. So that's still pi times, now the radius is x squared. So that's the radius squared minus the change, right? So that's dx. So look, basically, in each one of these terms, I'm integrating from 0 to 1. I got a pi in it, right? And a dx. So I could really put all this stuff together. That's pi. In fact, I had a pi from each term going from 0 to 1. I'm left with on this side x squared, or that's the radius x squared, then minus this radius x squared. So what happens when I do the wash? This is called the washer method. Well, all I have to do is do my outer radius minus my inner radius. So it's just like when we was doing the disk method. It's just that I'm subtracting off the radius that I don't need. So then when I integrate this, of course, this is going to be pi on the outside. This is x squared, basically, right? When I integrate that, add 1 to the new exponent divided by the old exponent divided by the new. So this x to the third, and 1/3 is going to be the coefficient. This is minus. Of course, x squared is x to the fourth. So add 1 going to be a 5. Divided by the new, that's 1/5. X to the 5th. And I'm testing this from 0 to 1. Well, remember that's that f of b minus f of a, but I know when I plug in 0 here, it's going to give me 0, so I'm only really paying attention to when I plug in 1. So when I plug in 1, you know what, I need to put my equal signs. When I plug in 1, I should have, that's going to be pi times 1/3 minus 1/5. And 1/3 minus 1/5 going back to pre-algebra. That's the 5 bow tie method, remember that? Or the tie method, I forgot what they call it. 5, right? It's going to be 5 minus 3. 3 times 1 is 3. All over 15. 5 minus 3 is 2. So it's going to be 2 pi over 15. And that would be my answer.